So now we will do a little mini lecture on RNNs. So there is a basic problem with just regular fully dense connected layers, and that is you need a fixed input size. So in other words, you can give it an image of, pixels, but if you want to give it, I don't know, what's a good sequence? Well, I'll just say a sentence. If you want to give it a sentence is hard because there is no fixed size for sentences, You can't give it 10 words and expect every sentence to be exactly 10 words. A sentence can range from, a couple words to many, a dozen words or, a few dozen words, I guess, if you want really long sentences. Technically infinite. So RNNs are hopefully a way to solve this, basically. And they can be cleverly used in a couple different ways to work with sequences as inputs and also output sequences, and in more advanced things they can turn sequences into other sequences. For example, translations. If you have an English sentence you want to translate it to Chinese, people can use RNNs to do that. But I'll just go over the basic idea. Essentially, you're going to run the network at different time steps. Okay, so say we have a sentence and we want to do maybe sentiment analysis is a good place to start. Okay, so I'm going to take a sentence, maybe from like a movie review or something, and say, is this sentence positive or is it negative about the movie? So here's a sentence. The movie sucked. Okay. And so the first step is basically turning the words into numbers, but I'm just gonna kind of pretend that we're not gonna do that, and I'm just gonna say I already have a number that means the, and I already have a number that means movie, and I already have a number that means sucked. Okay. And I'm not going to really go into how those are generated, but just assume that we can. And then I'm going to plug that into a neural network. I guess. I'm going to plug these in one at a time. So I'm going to plug in my word for the, and then I'm going to plug in Yep, there we go. I'm going to plug in my word for the, and I'm going to plug in the word for movie, and I'm going to plug in the word for sucked. Except, I'm also going to give the model its previous inputs, its previous hidden states, basically. And then at the end, I'm going to take its output and say, this is the sentiment. This is my answer. This is my guess for the sentiment. Yep, that's sentiment. And then when I backprop, I'm going to backprop through this specific time step, but also back this way through past time steps. And basically that's the basic idea of recurrent neural networks. So do we have any ideas or any questions so far?
Do you want to walk through, actually after they have questions, so
Yeah.
suggest this.
Okay.
I don't have any questions so far.
Okay.
Right?
Yeah, it makes sense.
Okay. Yeah. Do you want to walk through an example of just let's say sequence to sequence, just take in a phrase, turn it into a vector, and turn it back into a phrase in let's say French, or pretend it's French.
That is actually kind of hard. It's not trivial, but
yeah, I mean, just a little diagram is what I mean, because I think that would really help cement the understanding here. I can pull up a good diagram that I'm thinking about.
Yeah, why don't you pull up a diagram?
It's the one right there. Thank you.
Relevant to our thing though, something else that you can do with RNNs is you can have some things like a vector that just has information, and then we just chug it through a bunch of RNN layers, and it somehow like develops the sequential nature of. Does that make sense? Like it can help manifest it into a sequential state. It's like I have like I don't make any sense. You have like a vector, right?
Yeah.
And a vector isn't sequential at all. So like Alec mentioned, variable length is one advantage of RNNs, but also it's inherently read or generated sequentially, which is another valuable thing. And so what we can do is, even if we just have, like for example, like the image vector output, right? It's just like information, but then we chug it through a bunch of recurrent layers.
This is a little too big,
and
actually.
we get like a
but
sequentially generated
Something
output.
along these lines
So sequentially
makes sense.
So in that sense, it could be interpreted as like a language.
I think that'd be just useful to talk about. Maybe we could end the recording for now.
Okay.
Do you want to talk about this?
Sure. Yeah, the recording. Start now.